Okay, last example. Example 2, checking your zeros. In example 2, we want to decide whether the given x value is a zero of the function. So we're given a cubic function here, and we're told that x equals 4 is a zero, and we want to decide whether or not this is true. Okay, so we need to check what we're being told is true. In real life, this makes a lot of sense. I think a lot of us are used to getting answers in math, or in any class actually, and just getting an answer and just running with it. And in the real world, there can be a handful of different kinds of consequences for just going with your first instinct of an answer. You always want to make sure you double check what you're being told, because a handful of times what you're being told and what you think is true may not be that way. So especially in math, we always want to go back. If we're being told that something's true, we actually want to go back and make sure that that in fact is true, and we always want to double check our answers before we move forward, especially if our answers are going to lead us into doing a couple other things with that answer. So in example 2, we want to decide whether or not this 0 is a function. So since we're being told x equals 4 is a 0, we want to extract its factor, which we know is going to be x minus 4. So x minus 4 is the factor. And we're going to divide into our cubic function. Our cubic function here has all of our values represented and is in standard form, so I can just rewrite it the way that it was given to us. And now I can go through and long divide. My leading x on the outside is x, my leading x on the inside is x cubed. The difference between the two, what's missing, is x squared, so that goes up top as my leading x up top. X squared times x gives me x cubed now. X squared times minus 4 gives me minus 4x squared. I can subtract both my terms. Double negatives change to positive. That gives me 0. 3x squared plus 4x squared gives me 7x squared. My minus 5x I can bring down since I have two terms on the outside. Two terms on the outside, my x is my leading value. My 7x squared is my leading value on the inside. What's missing is my 7x, which gives me my next number on top. 7x times x now gives me 7x squared. 7x times negative 4 gives you now negative 28x. Subtract, my double negatives change to positive one last time. So this gives me 0, which is what I wanted, and negative 5x plus 28x gives me 23x, bringing down my positive 8. Leading x is x, inside x is 23x, so I obviously have a 23, a positive 23 that's missing. 23 times x now gives me 23x. 23 times negative 4 gives me a negative 92. It's a big number. Subtract again. Double negatives here give me a positive. That cancels out to give me 0. And 8 plus 92 gives me 100. Because I have a remainder, where my other examples I had no remainder. When I have a remainder, that means my original factor was not a 0. That was not a true 0. So the answer to example 2 is no, since my answer has a remainder. And number 2, I want to make sure that you guys have some time now to work on number 2. See if x equals 1 is in fact a 0 with the cubic x cubed minus x squared plus 4x minus 4. Make sure that you do your long division correctly. You may want to double check your answers at the very end. But you're looking for a yes or no answer for number 2. Is x equal to 1 in fact a 0? In example 2, our answer was no.